T cells are born in the bone marrow, like other blood cells. They then migrate to a certain organ. Do you know the name of that organ? I'll give you a hint. It starts with a T. That's right, the thymus. Once in the thymus, these progenitor T cells undergo positive and negative selection. For positive selection, the thymus releases foreign antigens that mimic bacteria, viruses, or other pathogens, and watches to see if these baby T cells will react like they're supposed to. If they do not react, then they are apoptosed. If they do, they move on to the next step, which is negative selection. Negative selection is when the thymus releases antigens that mimic tissues in the body. If these progenitor T cells react to these antigens, that's bad. You don't want your T cells attacking your body, so they are apoptosed. If they don't react, then they move on to either CD4 or CD8 matured T cells. CD8 cells, as we've discussed, induce apoptosis of virally or tumor-infected cells. How do they do this again? What's this receptor that they interact with? The MHC1 receptor. And again, when a fragment of a virus or a cell that has undergone malignant transformation is on the surface, is being presented by this MHC receptor, that cell is bad and it is destroyed via apoptosis. CD4 cells can develop into one of three types of further differentiated cells. Recall that CD4 cells are there for you. They're there for the immune cells, the cheerleaders. And they interact with antigen-presenting cells that bear MHC2 receptor. A quick way to remember which MHC complex interacts with which type of T cell is that the product is always 8. 8 times 1 is 8. 4 times 2 is 8. So the first type of CD4 cell, if subjected to interleukin 12, is the Th1. And Th stands for T helper. So it's a helper T cell type 1. What does this cell do? Well, it releases cytokines. This is the way it talks to other immune cells and says, keep going, keep attacking, keep doing it. I'm cheering you on. Specifically, it stimulates B cells. Now, do you know what antibody B cells initially synthesize? Well, first of all, they convert to a plasma cell, but the first antibody that they make, we said it earlier, it's the pentamer, the big one, IgM. So, let me ask you a question. How does IgG antibody ever get made? Well, it's by cytokines from the T helper cell type 1. That induces a class switching of antibodies to IgG, if it's the correct and specific type of cytokine. So, these Th1 cells also stimulate and cheer on macrophages to cause them to merge their phagosome with their lysosome and start chopping up pathogens. And pretty much they stimulate every type of immune cell, including CD8 cells and other types of T cells. If this CD4 progenitor cell is subjected to interleukin 4, then it will become a T helper type 2 cell. Now, when you say Th2, I want you to think Th2 achoo, because they mediate and encourage the allergic response. How do they do that? Same way the Th1 did it, via cytokines. All right, here's a B cell here that is synthesizing now IgE. So the cytokines induce the class switching from the Th2 cell to the B cell to make IgE instead of IgM. These IgEs are then deposited and resting on the surface of mast cells, which contain an abundant amount of pro-allergenic contents. So once an allergen is exposed to the IgEs on the surface of the mast cell, there's a cross-linking that occurs and a reaction that causes the mast cell to release and expel its contents and propagate the allergic response. The final type of CD4 cell is the T regulatory cell, after being subjected to TGF-beta. T regulatory cells control all types of T cells and immune cells in general. They're kind of like the orchestrators. Time for another flash quiz. Although both arise from the bone marrow, where do B and T cells actually mature? It's a nice little mnemonic. Bone marrow for B cells and thymus for T cells.